Thanks, Eric. Welcome, everyone. As Eric mentioned, my name is Chris White, and today we're going to briefly talk about one of my professional passions, virtualization. We're going to cover four main topics today. What is virtualization? What are some advantages and features virtualization gets me? When should I go virtual? And then finally, what does the future of the data center look like? Okay, let's get started. All right, before we get started with wrapping our heads around what virtualization is, let's take a step back and look at a very traditional server. In this diagram, we have a very basic server, which is composed of the physical hardware, the operating system that runs on that hardware, and then the applications that are installed and run on the operating system. The hardware is dedicated to that operating system and to the applications that run on that server. This means that the data center is going to be filled with racks upon racks of servers requiring a lot of cooling and electrical power, as well as more complex networking and limited security functionality. So how does virtualization improve all this? This is what a virtualization host looks like. Now, instead of an operating system being installed directly on the physical hardware, you have what's referred to as a hypervisor. This hypervisor, or as we'll refer to it going forward, the host, is a minimalized Linux kernel that's specifically designed to allow multiple virtual machines, or VMs, to run simultaneously on a single piece of hardware. So what does this mean for the data center? Well, instead of traditionally where you may install multiple applications on a single server to try and take full advantage of the hardware, now you can run multiple smaller VMs on a host, allowing your VMs to specialize in a single application or task. Since you are now running multiple VMs on a single host, your data center also shrinks in size, going from racks upon racks of servers down to one or two racks. And since you're buying fewer physical servers, the amount of hardware you can purchase for a server can go up as well, allowing you to have a better density of VMs on each host. Finally, the electrical and cooling costs for running this footprint in your data center goes down dramatically versus the traditional model. Now, hypervisors are only one piece to this virtualization puzzle, but they really form the base of what we're going to build off of today. So it's very important to understand those basics. There are a few different virtualization vendors on the market with their own flavor of hypervisor. Linux has KVM as part of most of their distros. Microsoft has Hyper-V. Citrix produces XenServer. But by far the most popular virtualization ecosystem in the IT industry is VMware, and the building block of that ecosystem is their ESXi hypervisor. So in VMware's ecosystem, once you have multiple ESXi hosts running in your environment and some type of shared storage, whether that be a SAN or a NAS, you can run an instance of VMware's vCenter and cluster all those hosts together and manage them from one location. Clustering your hosts together offers you a ton of additional features and advantages over running your ESXi host in a standalone configuration. To add further to this naming convention confusion, VMware vCenter and ESXi together make up VMware vSphere. For the rest of this talk, I'll be referring to vSphere until I specifically call out vCenter or ESXi. So let's take a dive on some of those features. One of the scariest things for an IT administrator to hear is your server is down, or getting that email from your monitoring software saying that it can no longer contact a service. In a traditional server configuration, I sure hope you have your application set up to be some type of active-passive setup, because otherwise your users are no longer going to be able to access that service. If you have that application virtualized and the VM running in a properly configured vSphere cluster, you don't have anything to worry about. vSphere offers a feature called vSphere Availability that can monitor and detect failures of running ESXi hosts. When a host loses power or crashes, the VMs that were running on that host stop running as well. vSphere Availability can detect that host failure through a variety of different means and power on those VMs on another host. As you can see in this diagram, we have two hosts running in a vSphere cluster with shared storage. When the second host fails, vSphere Availability detects the failure and powers on the VMs on the first host. The actual downtime of the VMs ends up being less than 5 minutes in most cases. In addition to protecting your VMs from a host failure, vSphere availability can also protect your VMs by preventing you from deploying too many VMs. The resources on an ESXi host are a finite number, and running too many VMs on a host will cause all of the VM's performance to suffer. vSphere availability, in the event of a host failure, will attempt to power on all of the failed VMs on that remaining host, unless otherwise configured. vSphere availability admission control can be configured to allow only a certain number of VMs to be powered on in a cluster so that it allows for a single host or multiple host failures. Another feature of vSphere clusters is the ability to migrate VMs from one host to another without losing any downtime. This allows the administrator to balance the workload of the VMs between the hosts of the cluster. This process, referred to as vMotion, also allows you to migrate all the VMs off of a host so you can perform maintenance on that host. In this video demo, we can see the administrator has 2 ESXi hosts in a cluster with shared storage. The VM is currently residing on ESXi-A, and the administrator has a continuous ping set up from his local machine to the VM. He can right-click on the VM in the vCenter interface and select Migrate, and now he can go through the process of selecting ESXi-B as the host he wants to move his VM to. Once he clicks Finish, you can see as I was saying, once he clicks Finish, you can see in the upper right-hand corner that the vMotion process has started. And after a couple of seconds, the migration will be complete. The VMs moved to ESXi-B, and the administrator didn't drop a single packet to the VM. Datacenter can also assist you by automatically balancing the VM workload across your hosts. This feature, referred to as Dynamic Resource Scheduler, or DRS, can evaluate your VM workload in a properly configured cluster and then intelligently migrate VMs when other VMs on those hosts start using more resources. If combined with another product named vRealize Operations Manager, or VROPS, DRS can predictively migrate VMs based on trend analysis that's collected and analyzed by VROPS. Finally, if paired with current generation hardware, vSphere availability and DRS can combine forces to migrate VMs before a failure occurs on a host by sensing when components of that host are going to fail. This won't always work, as some things like power outages are not always predictable. But if a host trips a sensor in, for example, one of its power supply units, vSphere availability and DRS can quarantine that host and vMotion the VMs off while you open a ticket with the hardware vendor to get that failing power supply replaced. All of these features are there to help in one singular goal: to ensure that your VMs and applications remain accessible 24/7. We really live in a world now that demands anytime access to data and systems, and VMware is really trying to help you by help you to deliver that by providing the tools and features to keep your applications accessible. Okay, so we've talked a lot about why Virtualized and how many great features it's going to bring to your data center. But as with everything in life, there are some things to keep in mind when deciding whether or not to go virtual and how to properly configure your VMs. The thing to keep in mind is that a VM cannot be regarded in the same way a traditional server was regarded back in the day. They may look and feel the same since they're running the same operating system and they run the same applications, but because a VM runs on a hypervisor and not on bare metal hardware, they are really completely different beasts. This is because VMs share the resources of the hypervisor they are running on. This allows you, as the administrator, to purchase a very large server, something on the order of 24 CPU cores, 512 gigs of RAM, 10 gigabit NICs, and then spread those resources to the VMs running in the hypervisor. Because the VMs share the resources, they can actually perform better than physical server counterparts, but they need to be configured correctly. Ideally, a VM should be configured with a single virtual CPU, or vCPU, and 4 gigs of RAM. This type of configuration is perfect for file servers, domain controllers, virtual load balancers, and just general application servers. When you start getting into applications that have larger resource requirements, those still may be indeed a valid configuration. Unfortunately, sometimes VMs are configured with too many resources from the start, or during a troubleshooting session, resources may be added to a VM to hopefully alleviate a potential problem. VMs with misconfigured resources are sometimes referred to as monster VMs. Incorrectly configured VMs suck up the resources of the hypervisor for themselves and don't allow other VMs to use those resources on the hypervisor. A tool that is very useful in right-sizing a VM is VROPS. VROPS collects statistics over a period of time and then can suggest whether a VM can run at the same performance level with fewer resources, or if it in fact does need more resources dedicated to it. The problem with throwing a ton of resources at a VM is one of scheduling on the hypervisor. On each hypervisor, there's a little module called the Virtual Machine Manager, or VMM. This VMM is responsible for placing workloads on the hypervisor's physical CPUs, and then removing those workloads when the operation is complete. When you configure a VM with 8 vCPU and 32 gig of RAM, the VMM has to find 8 available cores on the physical processor to place that workload, even if the application is a single-threaded application. So in this example, you will have 1 physical core executing the commands and 7 cores sitting unused, all reserved by the VM until that single-threaded application has finished its command. While this is occurring, your other VMs that may be configured with single or dual vCPUs can't be placed on any of those other 7 cores that are sitting unused because they're being consumed by the monster VM. This is why we say that a single vCPU VM can have better performance than even some physical servers, and why it's so important to the health of your virtualized environment to right-size your VM. In that case, the VMM has a much easier time placing the workload on any available core in the hypervisor instead of waiting for a bunch to free up all at once. There are still some use cases where virtualization doesn't quite make sense, although that use case is shrinking with every new release of vSphere. Today, if the application running on the physical servers requires some type of USB or serial dongle to operate, that server can't be virtualized without some type of specialized software. Some applications require very high and dedicated storage I/O to perform, and servers running that application shouldn't really be virtualized. Since virtualization really relies on shared storage such as on SAN or NFS shares to store the VM files, these storage arrays are not perfectly suited to handle extremely high dedicated I/O needs. Now, the caveat to this is that the storage space in the data center is rapidly changing, and there are newer systems and software out there to serve out storage much faster than even a couple of years ago. Finally, some application licensing schemas just don't support virtualization, with the most egregious that comes to mind being Oracle with their database and middleware applications. Now, on the flip side, VMware is actively working with software vendors to come up with guides on how to virtualize even the most resource-intensive of applications. They have even published white papers and validated architectures on exactly how to configure your environment to support and run some of the most popular and demanding applications. These include SAP HANA, SQL Server, Exchange, Apache Hadoop, SharePoint, and Skype for Business. Okay, we have talked a lot about virtualization in the present, so let's spend a minute talking about what virtualization is going to look like in the future. Where is the data center going over the next few years? We're quickly moving into an era of the data center where the hardware doesn't matter as much as the software running on that hardware. You'll often hear this referred to as the software-defined data center, where all of your services, including compute, storage, and networking, are now software-based instead of hardware-based. Let's take this graphic as an example. Here we have a typical virtualization stack, commonly referred to as a converged infrastructure. At the bottom of the rack, we have our shared storage array. Above that, a few ESXi hosts. A couple of storage switches above those ESXi hosts to connect the ESXi host to the storage array. And finally, a couple of network switches so that your ESXi host can connect to the rest of your IP network. Each of these different pieces of hardware handle some different aspect of serving out VMs and applications to your end users. So this can get extremely complicated depending on the configuration, and you really open yourself up to a bit more risk of a hardware failure affecting some piece of your stack. By utilizing software to handle the compute, storage, and network, now you aren't as reliant on the hardware, and new features or bugs can be easily fixed with a patch. By transitioning to a software-defined approach, your data center goes from multiple pieces of disparate and different hardware to just a stack of ESXi hosts. VMware's software-defined storage offering is called VMware vSAN, and when run on compatible hardware, it can take hard drives and SSDs attached to each host and aggregate them into a single virtual data store presented to the vSphere cluster. VMware NSX allows you to run virtual routers, switches, and firewalls inside your vSphere environment to handle all of your data center networking requirements, as well as segment off certain VMs or applications to better improve the security footprint in your environment. This is commonly referred to as microsegmentation. These technologies make up VMware's hyper-converged infrastructure, or HCI, offering, and are VMware's solution to the software-defined data center. There are other vendors also doing HCI in some form or another, with the notable ones being Cisco with HyperFlex, Nutanix, and HPE with SimpliVity. Cisco's HyperFlex is actually leading the HCI market at the moment with both available features and raw performance numbers. Hybrid cloud is another term that's being used quite a bit in the industry and has the potential to completely redefine the data center as we know it. The technology hybrid cloud refers to is the ability to extend your on-premise data center with a public cloud vendor such as AWS or VMware vCloud Air Network Service Provider. For some vCAN service providers, they even offer the ability to extend a layer 2 network from your data center into the cloud space and even migrate VMs from your on-premise vSphere environment to their cloud. This allows you to, for example, clone out an application server, migrate it to the cloud, and then test software updates without ever affecting your production stack. VMware has also made a lot of progress with Amazon and AWS to extend your on-premise vSphere environment into an AWS data center. This allows you to easily connect and take advantage of AWS's other services such as S3 storage, EC2 instances, and RDS database instances. Alright, finally, if a vSphere environment just sounds like too much for your environment, and there are other options to host all of your VMs and applications in the cloud. Service providers like AWS, Azure, and Google can offer you single predefined VM instances that they will host in their public cloud for you. vCAN service providers handle their public clouds a little bit differently, where they can either provide you with a single VM instance, or they can just provide you a chunk of resources composed of CPU, RAM, and storage, and then you decide how you want to spread those resources among your VMs. While offering greater flexibility for your environment, vCAN service providers offer you the most freedom in a public cloud setting. We've covered a lot of information today, really briefly. So if you want to discuss some or all of these topics in more detail, please reach out to your account manager and they will set up with a meeting with myself or one of our other VMware engineers. As an additional thank you for coming out today, along with your free Subway e-card, we're also going to be offering a free VMware health assessment. If you're already taking advantage of virtualization today, but want to make sure that your environment is set up correctly and optimized, contact your AM and they'll set up an assessment with myself or your IT staff. Additionally, I should mention that ALI is a vCAN service provider. So if you're considering hybrid cloud or pure public cloud for your environment, call us. We can help you make the right decision based on your company's needs. Again, thank you guys for coming out today. It was an absolute pleasure being able to talk about this passion of mine. At this point, we'll go ahead and open up the Q&A panel for questions, and I'll turn it back over to Eric.